All right, I wanted to go ahead and actually begin this first problem on the free response. And our approach is going to be pretty straightforward. We're going to start with a free body diagram of every object. So first we do a free body diagram. From there, we're going to get Newton's equation from the second law, F equals ma, the Newton's second law equation. And then from there, we're going to get the acceleration. We're going to use that to get any of the kinematics quantities, positions, times, and etc. that they want us to solve for. So to that end, let's actually begin with the free body diagram. So the block has a normal force on it due to the slab. There is weight on the block due to the earth. There is a friction force on the block due to the slab. And that's what we have so far. Now for the slab, things are a little bit different. We have the normal on the slab due to the earth. We have the weight of the slab due to the earth. And notice we've got the normal on the block due to the slab. That means there are a corresponding third law pair of the normal force on the slab due to the block. That's one third law pair. I'm drawing this off to the right because I can't fit it on the circle. It's a part of this free body diagram. And then we have the force of friction on the slab due to the block. That's the second third law pair. So we have this force dragging it forward. Now when we actually set up some equations here, I'm going to note that I have the force of friction pointing to the left on the block, and that has the effect of making the block accelerate. And in the y direction, we have the normal force balancing the weight. What that's going to do when I plug in 0.5 and remember that g is 10 meters per second squared, and with the formula weight is mg, I can substitute that into here. I'm going to get a weight of 0.5 times 10, which is 5 newtons. So my normal force ends up being 5 newtons here. And so I can actually use that fact in my friction equation. I have mu times the normal force equals ma. I can go ahead and solve for the acceleration, and that's going to end up being I need a negative sign here, negative 0.2 times 5 equals 0.5 times a. And so I'm actually going to end up getting an acceleration of negative 2 meters per second squared. Similarly, for the slab, I have a 1 Newton friction by Newton's third law. If I have 0.2 times 5, which is 1 Newton friction here, that means I've got 1 newtons of friction here. So I have 1 equals 3 times a. And so that's going to give me an acceleration of 0.33 meters per second squared. What I'm going to do in the next video is actually go ahead and solve parts B and C.